Today we're going to review solving inequalities. What is an inequality? It's a statement where two quantities are not equal. They compare two quantities using symbols, the greater than or the less than symbol. Here I have a few different symbols. We have the equal sign, we have the not equal, we have the greater than, the less than. Now if you throw an extra line on there, it's going to be a greater than or equal to, or a less than or equal to. If we remember back to elementary school, we learned inequalities as the alligator. The alligator always eats the larger thing. Here the alligator is eating the larger cupcake or the larger pizza. This will be a less than sign saying this cupcake is less than, or this will be a greater than sign saying that the piece of pizza is greater than. Remember to always open the mouth towards the greater number. Now, if we're going to translate these into English, we would say that 5 is less than x, and that's what you'd write. For the next one, there's a y, there's a greater than, but it's not just greater than, it's also equal to. So we would say y is greater than or equal to z. The solution of an inequality is any value that makes an inequality true. Sometimes they'll give you an inequality and they'll ask you, are these numbers a solution or not? All you have to do is substitute and simplify. For the first problem, they say that x is a 3. So I'm going to write 4 parenthesis 3 plus 5 is less than negative 3. 4 times 3 is 12 plus 5 is less than negative 3. 17 is less than negative 3. This is false, so we would say no. No, 3 is not a solution. For the next one, we have x is negative 1. I substituted the negative 1 in for x, and now I simply simplify. Again, that's a false solution. So we would say no. No, negative 1 is not a solution. And for the last problem, I substitute the 0 into the x, and I simplify. And we would say no, 0 is not a solution. Now we're going to talk about graphing inequalities. The graph of an inequality shows all numbers that make the solution true. Now this next part is incredibly important. Always put the variable on the left when graphing inequalities. If you have a greater than symbol, you're going to have an open circle and an arrow going to the right. If you have a greater than or equal to, then that circle is now closed and it's still going to the right. Less than, open circle to the left, less than or equal to, open closed circle to the left. Now let's take these graphs and turn them into words. Here I'm at negative 12, I have an open circle and it's moving to the right. We would say our variable is greater than negative 12. For the next one, we have a closed circle and it's going to the left. So we would say our variable x is less than or equal to, because it's a closed circle, to the 5. Now on to solving inequalities. The only difference between solving an inequality and solving equations is one major difference. When multiplying or dividing across an inequality by a negative sign, you must flip the inequality. This is only multiplying and dividing a negative, then you flip it. Let's do a couple problems to practice. I have negative 3x is greater than 15. I get the x by itself by doing the opposite. I divide by negative 3. What I do to one side, I do to the other. Divide by negative 3. Negative divided by negative cancels. 3 divided by 3 cancels. That gives me x. Now because I divided across an inequality by a negative, I flip the symbol and I have a negative 5. To the right, I have x divided by negative 5 is less than 22. The opposite of dividing is to multiply. What I do to one side, I do to the other. Negative 5 and negative 5 cancel out. That gives me an x. I multiplied across the inequality by a negative, so that's greater than negative 110. So if I multiply or divide by a negative, then I have to flip that inequality. Another quick, easy problem. I have x divided by 20 is greater than negative 10. So I'm going to multiply both sides by 20 to cancel those out. What I do to one side, I do to the other. 20 divided by 20 cancels. That gives me x. Now, I multiplied by a positive 20. It doesn't matter that there's a negative over here, but I multiplied both sides by a positive 20, which means my inequality is staying the same. And my answer is 20 times negative 10 is negative 200. Okay, let's solve and graph a couple more. I have 4 is less than 206 plus x. The opposite of adding is subtracting. So I'm going to subtract 206 from both sides, minus 206. This cancels out, which brings my x straight down. 4 take away 206 is a negative 202. Now, the inequality is facing to the left. I subtracted across both sides. The inequality is going to stay the same because I did not multiply and divide. However, I always need my x on the left-hand side. So that means I'm going to take this problem and I'm going to write it backwards. So we start with the x, then we write the alligator, and then we write the number. Notice the alligator is eating your x. So when we redraw this, the alligator has to keep eating the x. It's going to look like this. X is greater than, because it's being eaten by the alligator, negative 202. Now I need to draw this. So I'm at 0, negative 100, negative 200, negative 300. So I need to go just a slightly past negative 200, and it's greater than, so my arrow is going to go to the right. There's no equal sign, so it's open. So I'm going to have an open circle just to the left of 200, and it's going to move to the right. Another quick easy one was the opposite of dividing by negative 3, multiplied by negative 3. What I do to one side, I do to the other. Negative 3 divided by a negative 3 cancels out, and that gives me a positive r. Now, because I multiplied both sides by a negative, I'm going to flip the sign. Negative 3 times 1 is negative 3 halves. The r is standing on the wrong side, so I need to write it backwards. I'm going to start with the r, I'm going to write the inequality, and then I'm going to write the number. Notice the pointy end is pointing to the r, so I make sure when I rewrite it, I do that. R less than, the pointy end is pointing to the r, negative 3 over 2. Now when I graph this, I probably want negative 3 over 2 to be a decimal. So negative 3 over 2 is the same as 1.5. On my graph, I go to negative 1, that's negative 2, so I need to be halfway between. It says less than, so I have an open circle because there's no equal, and the arrow is pointing to the left. Notice this arrow is pointing to the left, so this arrow is pointing to the left. Now we're going to translate some sentences into math. It says a number k is increased by 1 is at most negative 2. So the number k, so I write myself a k, increased by 1. Well, if I'm increasing, I'm adding, so this means add, so plus 1. Normally is an equal sign, but this says at most. That means that it cannot be bigger than -2. It can be -2 because I have an equal sign. Is at most -2. So I'm going to say it can't be bigger than -2, which means k plus the one number has to be less than or equal to -2. Now I'm going to come to -2. It's a solid dot because of the equal sign, and the arrow is pointing to the left, so my arrow is going to point to the left. The next problem says a number t decreased by 2 is at least 7. So t decreased, that means subtract, by 2 means there's going to be an equal sign. At least. Well, if you have at least 7, that means you have 7 or more. So we would say greater than or equal to 7. When I go to graph it, I go over to my 7. It said equal to, so I put a solid dot. And the arrow pointed to the right, so I'm going to make my arrow point to the right. I'm going to have at least 7, which means I can have 7 or 8 or 9, etc. When I look at this problem, I see there's parentheses. So I need to distribute the 2 through. That gives me 2x minus 6. The inequality hasn't changed. It comes straight down. On the right-hand side, I see I have like terms, a 6 and a -3. I'm going to combine my like terms. 6 take away 3 is 3, and then I have a 3x. 3x plus 3. Now I want to get all of my numbers on one side and my letters on the other. I'm going to use the same rules as I did for solving equations. I want to keep my x's positive whenever possible. And that means I'm going to subtract 2x and subtract 2x. At the same time, I'm also going to try to get the 3 to the other side. Subtract 3 and subtract 3. When I simplify this, the 2's cancel out. -6 and -3 gives me -9. My inequality has not changed. 3x take away 2x gives me 1x. And 3 take away 3 cancels out. Now I'm almost finished, but my x is on the wrong side. So what I need to do is rewrite it backwards. Notice the pointy part is pointing towards the x. So when I rewrite it, it's going to be x is less than -9. I double check, pointy towards the x, pointy still towards the x. To graph this, I go to -9. There's no equal sign, so it's going to be an open circle, and the arrow is pointing to the left. So my arrow will point to the left, less than. Here's 2 more problems, both with distribution. Now I need all my x's on one side and my numbers on the other. I'm going to add the 3x to get it to move to the other side. And I'm going to subtract this 3 to the other side. What that gives me is 6 take away 3 is a 3. Those x's cancel. My inequality did not change. Those x's canceled, and those 3's canceled. Well, the only thing that's left is a 0. Is 3 less than 0? The answer is no. 3 is not less than 0. Because that is a false statement, we would say there are no real solutions. On the right-hand side, I need all my x's on one side, so I'm going to move this 4x to the right. Subtract 4x, subtract 4x. The 4x's cancel, and that leaves me with -4 is less than or equal to 0. This is a true statement. Notice, this is a true statement. Because this is a true statement with no variables, we would say all real numbers, which can be written with the Gothic R. If I was to graph this, I wouldn't have a dot anywhere. I would simply have a line that would cover the entire graph with arrowheads going both directions because it is all real numbers. Next, disjunction versus conjunction. A disjunction is a compound statement that uses or, and a conjunction is a compound statement that uses and. The key thing here, if it's or, the arrows are going in opposite directions. If it's and, the arrows are going to go in the same direction, meaning you're not going to have arrows, you're only going to have an overlap. Let's try a few. Here I have an and, which means I'm going to have a conjunction. What we do is we solve each of these separately. 3x is greater than negative 15, divide by 3, gives you x is greater than or equal to negative 5. On the right hand side, I have 7x is less than or equal to 21, divide by 7, x is less than or equal to 3. Now I'm going to graph these. Both of them say or equal to. Put a dot, closed circle at negative 5, and a dot, closed circle at 3. This says x is greater than, which means it's going to the right, and this says x is less than, which means it's coming from the left, which gives me a graph similar to this. This one is a disjunction because we see or. When we solve these, we have. Let's start with the x is greater than or equal to 7. I go to 7. I have an equal to, so I put a solid dot, and the arrow is pointing to the right. So my graph goes to the right. The next one, x is less than or equal to negative 3. I go down to negative 3. Because it said or equal to, I put a solid dot. The arrow is pointing to the left, so my arrow points to the left. This is a disjunction. It means you can have any number to the left or any number to the right. However, you can have no numbers between. And let's finish with a word problem. To pass a course with a B, a student must have an average of 80 or greater. Always mark your key information. They need an average of 80 or greater. A student's grade on the 3 tests were 75, 82, and 78. Find what score the student must get on the next test to get an average or better. Well, we know an average is all the numbers added up divided by that many numbers. So now we write down our key information, plus the unknown test. If this is an average, there's 1, 2, 3, 4 tests, so I divide by 4. Now we need 80 or greater. That means it can equal 80, or it needs to be greater than 80. So I have a greater than or equal to 80. Now we simply solve. I'm going to multiply both sides by 4 to get rid of the fraction. When I do that, the 4's cancel out. And at the same time, I'm going to add up my like terms inside, which gives me 235 plus x is greater than or equal to 320. In order to solve for x, I simply subtract the 235 from both sides. The 235 cancels out, giving me x is greater than or equal to 85, which means he has to score at least an 85 or greater in order to keep a B in the class.